So in the past, we've talked about all the big pieces of technology, things like hardware, software, networks, databases, but we've kind of looked at them one at a time in their own little silos.
Well, today we're going to put all those pieces together. We're going to follow one single tap on a phone screen and trace its entire journey, all the way to a server and back again. By the end, you'll have this really clear picture of how a modern app actually works, from start to finish.
Okay, so to make this real, let's imagine a simple app and our user who we'll just call Alice. We're going to follow her as she makes just one tap, and we'll see what's happening not just on her screen, but what's going on deep behind the scenes. So Alice opens the app, types in her name, and hits send. And boom, just like that, this personalized message pops up. It feels instant, right? Totally seamless. But in that tiny fraction of a second, her request just went on this incredibly complex journey. And that seamless feeling? It's all made possible by three main parts working together perfectly. First, you've got the front end. That's the actual app running on her phone. Then, way off on a server somewhere, you have the back end and the database. Honestly, these three things are the fundamental building blocks for pretty much every app you use every day.
All right, let's really get into it. We'll start at the very beginning, the moment Alice taps that app icon on her phone.
So the app itself lives in the phone's permanent storage. A good way to think about this is like a filing cabinet. But when she taps the icon, the phone doesn't work out of the filing cabinet. It makes a copy and pulls it into its active working memory, the RAM. You can think of RAM as your desk. It's much faster to work with things on your desk than to keep going back to the filing cabinet, right? That's why the app opens so fast. Everything it needs is right there, ready to go. And as she types her name, Alice, that information isn't being saved anywhere permanently yet. It's just sitting there on the desk, in RAM, held temporarily just for this one single action.
Okay, so now she hits send. What happens? The phone's brain, its processor, takes the name Alice and wraps it up into a special kind of digital message called an HTTP post request. You can just think of this as the standard way a device or a client sends new information to a server. So now this little package is all sealed up and ready to go.
And with that, the request leaves the cozy little world of Alice's phone and starts his big journey across the digital highway, all the way to the app's server.
But wait, how does it know where to go? Her phone only knows the server's name, something like helloapp.com, not its actual numerical address. So the very first thing it has to do is look up that address using something called DNS. DNS is basically the internet's giant address book.
Once it's got the address, the next step is super important. It secures the connection using HTTPS. What this does is it completely scrambles the data, including Alice's name, so that if anyone were to be snooping on the line, all they'd see is gibberish. It's totally unreadable.
Now this part is pretty cool. The data doesn't travel in one big chunk. It's broken up into little pieces called packets. And each packet has two addresses on it. First, it has the IP address. You can think of that as the final destination, the street address of the server. That one never changes. But it also has a MAC address, which is the address of just the very next stop, the next router in the chain. And that MAC address, it changes at every single hop along the journey.
So after jumping from router to router, all those little packets finally arrive at the server. They get put back together in the right order, the encryption is removed, and the original request is handed off to the real brain of the operation, the backend. The first thing the backend does is it tells the database, hey, log this visit. It sends a command to create a new entry, a new row, with Alice's name and the exact timestamp of her tap. Okay, visit logged, but now it needs some information. So it sends a second command to the database asking, how many times have we seen the name Alice before? The database does a quick count and sends back the answer, 3.
Perfect! Now the back end has all the pieces. It builds the final message, hello Alice, you have visited us 3 times, and packages that into a response. It slaps on a status code of 200, which is just tech speak for everything went great, and sends the whole thing zipping back across the network to Alice's phone.
And there you have it, the full round trip. It's incredibly fast, super efficient. But now, let's do that whole journey again, but this time, let's look at it through a security lens. Because every single one of those layers we just talked about is a place that needs to be protected.
Let's start with the front end with Alice's phone. The company that made the app doesn't own or control that phone. It could be lost, someone could steal it, it could have a virus on it. This is so important. It means the backend can't trust anything that comes from the front end. It has to operate on a zero-trust basis. It has to recheck and revalidate every single piece of information, basically assuming the phone is not secure.
Then there's the network. Remember all those routers the data hopped across? The app creators don't own any of that. The data is out in the wild. That's exactly why having strong, modern HTTPS encryption isn't just a good idea, it's a non-negotiable requirement under rules like GDPR. And here's the kicker. Using an old, outdated version of it is pretty much as bad as having no encryption at all.
This brings us to the backend, which is really the main line of defense. If the backend just blindly trusts the data it gets, like the name Alice, an attacker could send something malicious instead. They could craft a special name that's actually a hidden command, tricking the backend into, say, deleting the entire database. This kind of attack is called SQL injection, and it's how huge databases of customer information get stolen. And all of this really paints a perfect picture of a core security idea called defense in depth. The concept is simple. You can't rely on just one single security measure. You need layers. Because a single weakness, whether it's on the phone, on the network, or in the back-end code, can bring the whole system down if it's your only line of defense.
Okay, so let's tie this all together. What's the big takeaway here? It's that security can't just live in one spot. You have to work from a few key assumptions. Assume the user's device can't be trusted. Assume the network is being listened to. And that means the back end has to be the final, absolute gatekeeper that protects the data you're responsible for.
This whole layered reality, where one weak link can break the whole chain, it leaves us with a really critical question we have to ask ourselves about any system we're looking at. If any single one of these layers can fail, where does the real responsibility for keeping our data safe actually lie?